Week 6, Problem 5. For the circuit shown below, the ideal voltmeter reads 6.5 volts and the ideal ammeter reads 4.5 milliamps. Find the following. Okay, so this is pretty much the introduction to circuit analysis. So we know that R and the other resistor are in series, so the current between the two is going to be the same. So they want us to find the value of R. Okay, so we know the voltage across R, and we can find the current by finding the current through the other resistor. So if we find the current through this guy, don't need a C over there, through this guy, then we can find current through R, because it's going to be the same. So I'm going to start with V equals IR. There's no really good way of doing these sort of problems. Basically, you know Ohm's law, you know Kirchhoff's voltage law, you know Kirchhoff's current law, and you just fiddle around until it happens. You throw it all in a box, shake it up, look at what you had. If it's the right answer, you put it down. If not, then you shake it some more. So you can do anything you want as long as it's mathematically and physically sound. Might not get you the right, might not be the answer you want, but it should at least be correct. All right. So to find the current, we'll do I equals V divided by R. Trying to see. There we go. V divided by R. Alright, so over here then, we know that voltage, let's see here. Oh, we know the amps. Okay, never mind. We already know the amps that are going through R. So, R equals V, so, R equals, V divided by I. There we go. So 6.5 volts divided by 4.5 times 10 to the negative third on the bottom, which becomes 10 to the third on top. So 6.5 divided by 4.5 this gives us 1.4 repeating. So I'm going to call it 1.44. Which equals 1.44, and this will then be kilo ohms, which is why I took the 10 to the third and left it off the side like there. Bam. Okay, 1.44. I'm just going to write this guy up here, 1.44 kilo ohms. Okay, excellent. Find the electromagnetic force of the battery. Okay, so there's going to be a voltage drop across each resistor. So this voltage is going to start at something, and then it's going to drop by a value across the this guy. So the way we're going to find the voltage drop is V equals IR. We know we have, what is it, 4.5? 4.5. 4.5 times 10 to the negative third. 4.5 times 10 to the negative third. And then we have the resistance, which is 3. Times 3 times 10 to the third. These guys cancel. 4.5 is like 9. 9 plus 4.5 is, I'm going to say, it's 13.5. 13.5 volts. So I'm going to say that this side of the battery is going to have epsilon, whatever epsilon is, the electromagnetic force. Electromotive force, I believe. Basically, every time you see that, just think of voltage. It's measured in voltage. I guess for machines, they don't like to say what's the voltage of a machine, what's the electromotive force of a machine. It doesn't matter. Just say voltage. Alright, so it starts at whatever this value is. It's going to drop down. It's going to drop down again. And on this side, it's going to be 0. That way, the voltage difference across this battery is E. Because voltage is always a difference. So instead of saying the voltage difference, they just say E, where the which you're differing from, assumed, is 0. Alright, so here where I got this guy here is 13.5. So I'm just going to write that up here, just to delta V equals 13.5. Got it. Alright, so now we can do the same thing up here. We already know what up here, we don't need it. 6.5. Bam. This guy is 6.5. Delta V. Alright, so now what we're going to do is we're going to find the voltage of each section. So this section of wire is going to be 0. this section is going to be 6.5 higher than 0, which is 6.5. And then this section right here is going to be 13.5 greater than 6.5. So 0.5, add 0.5, we get 14, we get 20 volts. So this section is going to be 20 volts, which is going to be equal to E. E. The other way of doing this is we can find an equivalent resistance. So that's one way of doing this. That's kind of my preferred method, but the other way works just fine. So it's mathematically equivalent. So we're going to find an equivalent resistor. So we're going to redraw this circuit like so. So when we redraw the circuit, we're going to have a battery, we're going to have a resistor. This is going to be R, I'm going to call it equivalent, which is the equivalent resistor of the two added together. Since they're in series, the way you combine resistors in series is you add them. So we're going to do 3 plus 1.44, which is going to be 4.44. 4.44 kilo ohms. So we same do V equals IR, where I in this case is 4.5 milliamps. So 4.5 times 10 to the negative third times 4.44 times 10 to the third. Cancel, cancel. Oh, cancel the whole thing. There we go. And let's do 4.5 times 4.44. 4.5 times 4.444. And we get 19 point, I'm going to round that up to 20, which is good because if it's shown up as a different number, I would have looked really dumb. 20 volts, which is the same answer we got over here. So the electromotive force for the battery is 20 volts. So now they ask us what's the voltage difference drop across the 30 kilo ohm resistor. So I say voltage drop here because when you're going from a high voltage to a low voltage, you're going to have a drop. Then you're going to have another drop until you get to 0. And if you're going the other direction, you have a voltage rise because you go from 0 higher, which would be kind of like, you know, kind of like a rise. So obviously the way they wanted us to do it then was to use these resistors and use an equivalent resistor and find it that way. Because the way I did it with the 13.5, by finding the drop across this resistor first, I basically just found the third answer before I found the second answer, which is fine. That's because there's so many different ways to do these problems that as long as you get a way that's right, it doesn't really matter. So 13.5. And that is how you do your first circuit analysis. So I think we'll probably be doing a few more of them, and we'll be moving on from there. All right, see you on problem 6.